Okay, so this is the next lesson in geometry. This is Unit 5, Lesson 4, and it's called Parallel Lines and Proportional Parts. Okay, so non-parallel transversals that intersect parallel lines can be extended to form similar triangles. So the sides of the triangles are proportional. Okay, so here's our first theorem. It's a big theorem. Okay, the triangle proportionality theorem. It says if a line is parallel to one side of a triangle, so line BD is parallel to side AE, and it intersects the other two sides in two distinct points, then it separates these sides into segments of proportional lengths. So for example, if we knew that BD is parallel to AE, then it means that we can say BA over CB equals DE over CD. Or you could say CB over BA equals CD over DE. Either one is fine. Okay? That's the triangle proportionality theorem. Okay? So pause the video if you need to look at that some more, just to visualize it longer. But that's the theorem that I just gave you. Triangle proportionality theorem. So if you look at example 1, we are going to actually prove that theorem that I just gave you. That's why I like geometry more than algebra 1, is sometimes you can see why things are true. So we're actually going to prove that theorem that I just gave you, so you can see why it's true. I like this proof. It is a long proof, though. So given that BD is parallel to AE, that's my first statement. That reason is given. We have to prove that BA over CB equals DE over CD. And here's how I'm going to do it. For step 2, I am going to say that angle 1 is congruent to angle 4. And angle 2 is congruent to angle 3. Do you know why? Think back to Unit 2, I think, or Unit 1. We did it in the beginning of the year. I definitely gave you the name for it in Unit 2. It's called the corresponding angles postulate. So now I can say the following. Since I know angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3, I can say that triangle ACE is similar to triangle BCD. Do you know why? Angle similarity. Okay, so I just showed that I just proved that the two triangles are similar. That's great. So since they're similar, it means that their sides are proportional. So it means I can say that CA over CB equals CE over CD. That's the definition of similar triangles. Since they're similar, it means their sides are proportional. Definition of similar triangles. Now check out what I'm going to do. I'm going to say that CA equals BA plus CD. I mean CA equals BA plus CB. BA plus CB. And I'm going to say that CE equals DE plus CD. Do you know what that reason is called? Think back to Unit 1 and Unit 2. That is the segment addition postulates. segment addition postulate. When I take a big segment and say it equals all the small segments added together, that's the segment addition postulate. And now look what I'm going to do. For step 6, I'll write it first, and you see if you can figure out what I'm doing. I can say BA plus CB over CB equals DE plus CD. Over CD. What is that reason called? Look at steps 4 and 5. I took this and I replaced it with CA. I took this and I replaced CE. So substitution property. So now what I can do is I can break apart this fraction and I can rewrite it like the following. I can say BA over CB plus CB over CB equals DE over CD plus CD over CD. That's just rewriting the fraction. I'll say rewriting the fraction. I'll just say, yeah, rewriting the fraction is what I'll call that. Step 8. I'm going to replace CB over CB with 1. And I replace CD over CD with 1. I'm going to call that simplifying because I'm really simplifying there. Now, if you think back to what you had to prove BA over CB equals DE over CD, and we have arrived at that point for step 9, finally. BA over CB equals DE over CD. And that is called the subtraction property of equality. Is that a proof I would make you do on a quiz? Not really, but I think it's good to see it, to see why the theorem I just gave you is true. And that theorem proves it. So we just proved that theorem. We just proved it. Excellent. Now let's solve an actual math problem with numbers in it, okay? Based on the theorem I just gave you, in triangle EFG, EH equals 9, let's label that. GH equals 21, let's label that. And FL equals 6. Find GL. All right, so let's use the theorem I just gave you. Let's do 9 over 21 equals 6 over GL, I'll just call it. Cross multiply and solve. 9 times GL equals 6 times 21. So 9 times GL equals 126. And then do 126 divided by 9, and you get GL equals 14. So that makes it easier. I mean, in the past, if I had you solve this, you would probably have to do like 21 over 30 equals x over x plus 6 and solve that. But we can use the theorem from the first page and just do this. 9 over 21 equals 6 over GL. Now, the converse of the triangle proportionality theorem is true. So if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. So this is the converse of the theorem from the first page. It is true. So we'll do a problem on that in 1 second. Okay, so here we go. Example 3. In triangle HKM, HM, which is this entire side, equals 15, and HN equals 10. So let me label that. HN is 10. Okay, so we just said the entire side was 15. So if this part is 10, this bottom part has to be 5. And it also says HJ is twice the length of JK. We know nothing about that side, but we know that HJ is twice the length of JK. So let's label JK as X. And if HJ is twice the length of JK, I'll label HJ with 2X. And the question is, determine whether NJ is parallel to MK. So we're going to use this, the converse of the triangle proportionality theorem. If the two sides are proportional, then it means that BD is parallel to AE. So let's see if they're proportional. Let's start with this side. Let's do 10 over 5. And when we simplify that, we get 2. And then let's do the same thing for the side. Let's do 2x over x. And when you simplify that, you also get 2. So the sides are proportional. So yes, NJ is parallel to MK. So I'll say yes, NJ is parallel to MK, and I'll explain why. Because the sides have proportional lengths. Or the sides are proportional. Okay? Okay. This next definition is called a midsegment. A midsegment of a triangle is a segment whose endpoints are the midpoints of two sides of the triangle. Every triangle has 3 midsegments. Okay, so just really quick before I go over the theorem, BD is a midsegment, okay, because it goes to the midpoint of this side and the midpoint of this side. It's called a midsegment. A segment whose endpoints are the midpoints of two sides of the triangle. Now, we have what's called the triangle midsegment theorem, which we won't prove. I'll just give it to you. It says a midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So since BD is a midsegment, it means that it's going to be parallel to AE, and it's half of AE. So if AE was 50, that means that BD is 25, and so on. Let's do one example on that. Example 4, find DE and PR. Okay, so you can see DE is a midsegment because it's at the midpoint of CP, because CD is congruent to DP, and it's at the midpoint of QR, because QE is congruent to QR. So there's two equations you could write to solve this. I think it's easier to think about it like this, okay? To avoid fractions, well, you could say DE is half of PR, but then you might have fractions. So I like to do it like this. I like to say that 2 times DE equals PR to avoid the fractions, okay? You could say DE equals 1/2 of PR, which is fine. Then you might have fractions. So I'm going to do 2 times DE equals PR. Okay? So 2 times 2x minus 11 equals PR. Oops, I should probably replace that. 1 second. Okay, so I just replaced PR with 5 plus x because PR equals 5 plus x. And let's solve this equation. Distribute 4x minus 22 equals 5 plus x. Subtract x, add 22. 3x equals 27, x equals 9. That's great, but now let's find DE and PR. DE equals 2x minus 11. So 2 times 9 minus 11. DE equals 7. Now you should know right away what PR is. PR has to be double that. Well, let's just double check to make sure we did it right. Because PR equals 5 plus x. So 5 plus 9 gives you 14. So I know I did it right by double checking. What are the odds? What are the odds of making a mistake and getting an answer that actually makes sense? Very small, probably. Okay, 2 corollaries, which are like mini theorems. If 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So we could say that AB over BC equals DE over EF. And if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if you knew that AB was congruent to BC, suppose you knew that. If you knew AB was congruent to BC, then you can conclude that DE has to be congruent to EF. Okay? So I think we have 2 more examples. Example 5, find x. Okay, so let's see. What do we have here? So we have, this has to be 6 right here, because that entire segment was 10. So if I label that as 6, now I'm going to apply the theorem I just showed you, or the postulate I just showed you, or the corollary I just showed you, this one down here. So to solve that for x, what I'm going to do is I'm going to do 2x minus 10 over 9. Wrong number. Let me fix that really quick. Okay, so I fixed that. It should be 2x minus 10 over 9 equals 4 over 6. And now we're going to solve that proportion. Cross multiply. 6 times 2x minus 10 equals 4 times 9. Distribute 12x minus 60 equals 36. Add 60 to each side. 12x equals 96, which means x equals 8 when you divide. Okay? And let's do this last problem. Find x and y. So this is going to go back to the corollary at the bottom of the last page, where it says, the one where I said, if you knew, for example, that AB was congruent to BC, then you can conclude that DE is congruent to EF. So since you have AB being congruent to BC, you can also conclude that DE is congruent to EF. Right? So that's what we're going to use for this problem. But let's start with the x. Okay? So we know that AB is congruent to BC. We know that. So we know that their measures are equal, so AB equals BC. So 3x minus 4 equals 6 minus 2x. Solve that for x. Add 2x and add 4. And you get x equals 2. Now let's focus on the y's. We know that DE is congruent to EF. We were not told that, but we could conclude that based on the corollary on the previous page. So it means that DE equals EF. Okay, so it means that 5/3 y plus 1 equals 3y. Now, this might be a little tricky, but if you want to get rid of the fraction, what you're going to have to do is you're going to have to multiply everything by 3. So you're going to have to do 3 times the first term plus 3 times the second term equals 3 times the final term. The reason why I'm multiplying everything by 3 is because that's my denominator, and that will clear the fractions. Because when I multiply by 3, there's no more fractions, because 3 times 5 over 3y equals 5y. Plus 3 equals 9y. Subtract 5y on each side. 3 equals 4y. And then divide by 4. So you get a fraction, which is okay. 3/4 equals y. Y equals 3/4. Okay. So that's the end of that lesson. That lesson was called Parallel Lines and Proportional Parts.